Good morning, good afternoon, good evening. Welcome to this 20th webinar organized by Eijkelkamp North America. I'm happy to say that today we will be talking about something that was requested to talk about CPT and pile driving. The challenge that I have is to use this time period of about 25 minutes to give you an overview, and in a way that is way too short, but I hope to give you a flavor of what CPT can mean for pile driving and how all aspects of pile driving, whether during the engineering phase, during the design phase, during the execution phase, during the planning phase, you name it, yeah, CPT really should be utilized. And that's why I call CPT and pile driving a great combination. Now, there may be some of you that have not been watching previous editions of this webinar. Some of you may have, and if you have been watching before, you have seen this slide probably by now so many times that you can, you know exactly what's on there. But for those of you that are new, just let me very briefly explain what CPT is all about. What you see on the left-hand side is a graphic where a truck, in this case, but it can be any other vehicle, is used to bring a pusher to a job site. And with that pusher, we then push a cone in the ground, and that cone that you see enlarged there measures the tip resistance, the pore pressure, and the sleeve friction. And that cone is pushed in the ground at a constant speed of 0.8 inches per second or 20 millimeters per second. And the reason why we do that and why we also have standardized the dimensions of the cone is that we don't take a sample, but by having a very standardized method and a standardized piece of equipment, we can correlate those readings that we're getting to get a very good understanding of what the soil behavior is going to be. And basically what happens is when you come to the job site and you start pushing the cone, you start getting your three lines, your squiggly lines, as Paul Main refers to them. You get your cone resistance, you get your sleeve friction, and you get your dynamic pore pressure. That gives you then, as I mentioned before, an indication of what the soil behavior classification is. Not what the soil is, but what the soil behavior classification is. And when you think about it for pile driving, when the pile goes in the ground, that pile can care less whether the soil is black or yellow, whether the soil is coarse or fine. What that pile cares about, because that is what it determines the bearing capacity, is what kind of behavior that soil has. The other thing that's important to know is that when you push the cone, you basically issue a report in about 25 minutes after you arrive at the job site, which means that while you are there, you get instantaneous feedback on what the soil behavior is, and it allows you to make a decision on the spot, whether to get more information, whether to get information in a slightly different location, but you get information feedback almost instantaneously. Not compared to a whole bunch of other site investigation methods where you will have to wait days, if not weeks, before you finally get some specific information. And that is very important as we are looking at how you can apply CPT when it comes to pile driving. Now, before I start saying how you can do it, I want to, and I have to show you this, what not to do. Believe it or not, quite often people tell me, well, yeah, CPT is great, but I really don't know how to analyze or design or interpret the data. Yeah, I'm used to SPT. So can you do me a favor? I'll ask them, okay, what's that? They say, well, you do your CPT because my boss wants you to do CPT or my client wants you to do CPT, but please use some kind of correlation to convert those data back to an N60 value, because then I know what to do. And of course, in the end, if that's what the client wants, that is what we will give the client. But please don't do that. Don't just go back. Use the CPT data direct for all phases of the project, as I will show you, at least give you an indication of flavor during the remainder of this presentation. So What to do with CPT data when driving piles. As I already told you, you should do that for the entire pile driving project. That starts at the very beginning when you have a preliminary or a final site investigation. You then start doing your foundation design based on your engineering of the pile. And then you go to the execution phase. First, the planning of the execution phase, and then finally during the execution phase as well. And what I will try to do is give you some indication of what you can do during each part of this project. And again, it's important to remember that you get those results from CPT in minutes, because that will help you better understand where some of the issues are coming from. So let's start with the first part. You've identified a job site. You know roughly what you're going to design there, what you're going to build there, and we need to start doing a site investigation. Well, I want to illustrate that by a project that was performed in the Netherlands, an apartment building that you see there, at least a drawing of that, an illustration of that building, about 4 to 5 stories, no basement, and a footprint of about 160 by 110 square foot. Once the job was identified, or the project was identified, they did an initial site investigation. You see those here, about 200 feet apart. 2 CPT soundings were done. And those soundings caused some issues, because what you see on the left-hand side is location number 1. You basically see that you have in the green box a fairly stiff layer that you can use for the bearing and bearing of your piles. But at location number 2, only 200 feet away, there was no such thing. It was basically a heavy soup. There was no clear bearing layer, and therefore you would have to apply friction piles there. So after the second sounding was done, about 25 minutes after that was started, we knew that we had a problem. We knew that there was such a site variability that before you could design your foundation properly, you better did something more. And that meant that there was some extensive follow-up. Extensive in the sense that 22 more CPTs were planned. The contractor wanted to play it safe, and you see here the locations of those additional CPT soundings that were ordered. When that was done, it was somewhat clear, but not really all that much. If you put all the profiles side by side, it seemed that as you were going from left to right, that bearing layer went deeper and deeper. But then when you went somewhere in the middle over here, you really didn't know anymore how the layers connected, what was going on, that bearing layer seemed to disappear altogether, or maybe it went kind of back up again to the surface. Who knows what was happening? Major uncertainty. Fortunately though, because the results were transmitted instantaneously, a decision was made before the unit was demobilized to say, okay, let's just play it safe, stay another day, and do a couple more. So in the end, we ended up with 46 CPTs, which means 1 CPT for every 400 square foot. Tremendously high number of CPTs, it seems, but at least we felt that based on those 40 CPTs, we would have a very clear idea what the site variability was. And sure enough, we could clearly identify with it based on those soundings what you were having. You saw here that the bearing layer went deeper and deeper. Then in this area B, there was no clear bearing layer. And in area C, the bearing layer appeared again and went again still deeper. But at least we had a very good idea what the site variability was, what the site conditions were. Summarize that is that in clear areas A and C, you had a clear bearing stratum. In C, deeper than in A. And in area B, there was no layer like that available. And therefore, you had to figure out where you were going to put the pile, how you're going to create this friction pile, but also remember that you had compressible layers directly below the possible pile toe level. Bottom line though is that because you did this, and because you get the information straight away, you could identify almost instantaneously that you had this site variability. You could take corrective action, and that meant that you were able to figure out a good site investigation so that you know what to expect, what kind of soil conditions you would have to design for, and what would be the input for your engineering and for your design. So that's the first phase. Then we go to the second phase. Soil investigation done. We now go to the foundation design. In one of the previous webinars, I have given you an indication on how the design of the foundation could be done directly on CPT, and I don't want to repeat it. If you have questions about it, you can either go to the Eijkelkamp YouTube channel where you find that old webinar, or you can just send me an email and I will more than happy to share that with you. But what I want to identify though, or emphasize right now, is that what are the consequences if you have not done this additional site investigation, if you have not used CPT to figure out what was going on? If you had decided to design your piles based on location A, most of them would have been too short, which means that the contractor comes to the job site, has ordered the piles, start driving the piles, and he won't get the refusal that is expected and doesn't know what to do. Has to start extending piles, all kinds of problems. On the other hand, if you had decided to use location C as the basis, because you only had done a site investigation there, the problems would even been much more troublesome. Most of the piles would have been too long. And when a pile is too long, then the tendency is to say, okay, just keep driving, keep hammering the pile into the ground until the top of the pile is at the right elevation. Whether then the toe of the pile has indeed gotten deeper into the soil or has been damaged, it remains to be seen. Either way, you have problems with the pile installation. So now it's no longer just a problem for the engineering firm because they've over-designed the foundation. You also have a problem with the contractor because it takes a lot longer to get the piles in the ground, all kinds of questions, what's going on. And then whether you used location A or location C, for all the piles that had gone in the area where profile B was applicable, you would have had a failure foundation. And basically, you would have insufficient capacity because in area B, you will only have capacity based on the friction along the pile shaft, but you did not have any end bearing, and therefore you did not have the right amount of capacity. And on top of that, as already identified, you had these soft layers underneath the pile toe, which would mean that the foundation would have a low stiffness. In either case, you would result with a failure of the foundation. But since we had good CPT data, since we could use and identify for all the piles what the soil profile was at that area, you can design such a way so the design is what you need. Based on the soil investigation, you know what to expect. And now in the design, you can make sure that you design what you need. Well, that's for the engineers among us. That's what I often hear. And when I talk to pile driving contractors, they say, well, Gerald, CPT is nice. Yes, yeah, it's beautiful. I believe you, but it's not for me. It's for the engineers. They can do that stuff. Hopefully they'll design it based on CPT data, but why would I need CPT information? And more importantly, why would I need to have a CPT rig on the job site as I'm executing my job? Well, let's start with the first part here, and that has to do with the planning of the job. Planning not necessarily of the whole project, but the planning of the project execution, the pile driving simulations. I'm a strong believer in PDCA. PDCA in the United States is the Pile Driving Contractors Association, and I'm very happy to talk to them later this week about this same topic, about what it means to, or how you can use CPT when it comes to pile driving. But I'm used to talking about PDCA as plan, do, check, and act. So first we're going to plan our job. And that means that you have a CPT profile, which you see here on the left-hand side, a typical CPT profile where the bearing capacity, the tip resistance, I should say, is indicated in the dark blue line. That can be transferred straight into a soil model that can be entered in most CPT or soil pile driving simulation programs. Yeah, I've used here Elwave for PDP, one of those programs, but you can basically take the CPT profile, enter that into your program, and you're going to get a soil model. And with that soil model, you can then immediately get a prediction of what kind of blow count you can expect if you drive a certain pile with a certain hammer into the ground. So all you have to do now is, you already know what kind of pile you have, because that is the result of the engineering phase. You think what kind of hammer you should be using, and then you just come up with what is the blow count that you can expect for the installation. With that, you now have a clear plan that you can start to perform. So with your drivability, you know what it will take to put the pile in the ground, and you will also know that it is more than likely to work what you have in mind, that your hammer is heavy enough, has sufficient capacity to drive the pile in the ground. That's you're in the planning phase. And you say, okay, that's fine. I can see that. That's kind of convenient that I can take the CPT data and use that CPT data to come up straight away with my drivability study, that I can just enter the CPT data into my program. That's nice. But that's kind of what I'm used to anyhow, because I normally enter those end data. But remember, the end data only gets you every 5 feet or so. And here I have a continuous profile. But that's fine. It still doesn't answer why I need to have a CPT truck, or CPT unit on the job site, especially during for larger CP or pile driving jobs. And that brings me to the last one. It's problem solving during pile driving. Think about it this way. Let's go back to that example that I gave you a little while ago. You see here on the left side was kind of the example for area A, the right-hand side, area C. This is what you were told to expect on the right-hand side. So the bearing layer would be somewhere around what you're going to get, where the green arrow that you see there, where that begins. So you think that you will have to drive the pile at least to this length. That's what you were told to expect. But this is what happened when you were driving your pile. You were not in this area to the right, you were in an area that is represented here by this graph on the left. So suddenly you started having all kinds of problems much higher up, and you could not drive your pile. And then the question is, what are you going to do? Because we can look at the pile, at least the part that's above ground. We can look at our hammer to see whether the hammer is working properly, but we cannot look down in the soil. And we don't know what's happening. Is it an obstruction? Just an obstruction that is only, say, a rock or some piece of debris or whatever, something buried. Quite often, it's amazing what you can find. Yeah, you may not have that. You don't know that because you cannot look into the soil. If you then can do an additional soil investigation to figure out what is the obstruction. Yeah, in this case, we already know that it's because of site variability. But if you haven't, if you have missed that, or you haven't done an extensive soil investigation, you don't know what the reason is for the obstruction. And by doing a CPT sounding right then and there, you can find out what is happening, why you have this obstruction, why you have these problems driving the pile. Similarly, if you going back to what I said earlier in the drivability study, if you have done your plan and you come up with an expected blow count as a function of depth, and you suddenly find out that the blow count is completely different, you can either say, well, yeah, it's just different and hope for the best, or you can do an additional sounding and use that information, do that sounding right next to the pile that you're driving to get a better idea of what the soil conditions are there, then run your program and get a better understanding of what should have happened for that pile that you're driving, so that at least you can figure out why you have the issues that you have. So the advantage of having CPT equipment available on the job site is so you know what is going on. Now, I fully understand that for a job where you just have a few piles, it doesn't make any sense to bring a CPT unit to a job site. But if you have a job where you drive hundreds of piles, this is a very cheap and efficient way of addressing problems. You all know what it costs to have a pile driving contractor on standby, trying to talk about, hey, what do you think? What would be the issue of this problem? What would be the cause of the problem? How can we resolve it? If you can just put an additional CPT cone in the ground, in 25 minutes, you have a much better understanding what's going on there, and you in the end might save a ton of money. So, what is CPT? Yeah, I hope to have given you, at least in these last 20 minutes or so, 25 minutes, an idea that it is an exciting and efficient soil investigation method. Gives you a continuous profile, but it's suitable for all phases of the pile driving project. And I really want to emphasize that it's not just only a good tool during your design and engineering or your original planning project, it's also a great way of figuring out problems, planning of the execution part of the pile driving part, but also, and not just the planning of the pile driving, but also during problem solving. And that's why I call CPT and pile driving a great combination. That's kind of the introduction that I had. A couple of questions that have come in. One question is a very interesting question that comes back time and time again. In most cases, the variability must be assessed before pile driving. We cannot perform a late evaluation if we're committed to using precast piles. Any comments? Well, yes, I do. Quite a few, actually. First of all, if you have precast piles, it basically means that you cannot really extend them all that easily. It's another reason why you need to really go and do an extensive soil investigation to make sure that you have your variability that you see here correctly identified. And quite often, and I think most of you will face that issue time and time again, there is no money to do extensive soil investigations. There's money in the end to address the problems that you have created as a result of insufficient soil investigations, but it's a different story. And that's why I'm also moderating every other month a webinar series with the Deep Foundation Institute talking about it's money. Increased testing saves money. More extensive soil investigations makes sense. Yeah, it solves you these problems. Secondly, we need to maybe think about the type of pile that you're selecting. If you don't do a sufficient or an extensive soil investigation, if you just trust on a preliminary soil investigation and hope for the best, maybe concrete piles are not the best solution. Maybe that's something that you need to take into your risk evaluation. Does it make sense to use concrete piles? Because what happens if I come up with site variability more than what I expect? How am I going to address it in my pile driving? Third, we need to always use local experience. The project that I gave you here, the people that were from that local area, they knew that site variability was probably very likely. engineering firm from somewhere else may not realize that. So local information, local knowledge is very important that you identify the potential for site variability. And what you see is that I'm trying to paint a picture. Now, there is no clear answer. It's not like you cannot use concrete piles, or you have to do this, or you have to do that. You have to put everything together, but in your evaluation, you definitely have to take into account the potential for site variability and what it then would mean for your execution of your pile driving project. One more question that I think I have time for. Is pile driving simulation a replacement for a test pile? Pile driving simulation, in my mind, can very well be a replacement for a test pile. If you have a good soil investigation and on that basis design your pile and derive your bearing capacity, and you then show that during the pile driving installation or the pile driving itself, the predicted results very closely match the actual results, you may not need a test pile anymore. And that's why I strongly believe to do a CPT and don't necessarily have that many test piles. As a matter of fact, in the Netherlands, quite often you don't do even a load test on a pile. You basically do more extensive soil investigations, and then on the basis of your CPT, you trust that the pile has the right capacity. Okay, one more final question. A pile driving project. What are all the phases of a pile driving project? Well, as I told you before, as far as I'm concerned, the pile driving project that you have, let me really show you all the phases here. A pile driving project starts with the initial soil investigations, then your design and based on your engineering, the engineering figuring out what kind of capacity you would need, design a pile accordingly, then do the planning of the execution phase, and then go on with your the problem solving or the monitoring during the pile driving itself. Because only once the pile is in the ground and you're sure that the pile is in the ground without any damage is your pile driving project complete. There are a couple more questions in there. Unfortunately, I will not have time to answer that because we try to keep these things limited to 30 minutes. So let me leave it at this. I look forward to seeing you again next month when we talk more about CPT. Thank you very much.